Good morning all. So in today's class we will look at a few theorems and few definitions on the basic theory of linear systems. Now if you have an nth order linear differential equation, so you have already studied the basic existence theorem, then you have studied what is the form of solution and what is the meaning of linear combination of solutions, then what are the meaning of linearly independent and linearly dependent solutions. So analogous to this, you have the same theory applicable in the case of a linear system of equations. So in today's class we will see the analogous theorems and the analogous definitions. So first we will look into what is the basic theory of basic existence theorem for an nth order linear differential equation, and then we will go on to the linear system. So if you are given an nth order linear differential equation of this form, so the basic existence theorem states that provided your coefficient functions, so this is the differential equation a0 a1 an minus 1 and an, they are the coefficients of the linear differential equation, and f of x is the right hand side function. So basic existence theorem says that a0 a1 an and f, they must be continuous real functions on the interval a less than or equal to x less than or equal to b, and a0 of x, it is not equal to 0 in the interval ab, and then for any x naught belonging to AB and for any arbitrary constants C0, C1 and Cn minus 1, then there will always exist a unique solution f such that it satisfies the condition f of x naught equal to C0, f dash of x naught equal to C1, fn minus 1 of x naught equal to Cn minus 1. So which is defined over the interval a less than or equal to x less than or equal to b. So the differential equation together with these set of equations, so here you have n equations, f of x naught equal to c naught, then up to fn minus 1 of x naught equal to cn minus 1. So there are n conditions. So this is an initial value problem. So the differential equation together with the conditions given at the point x naught, that's an initial value problem. So the basic existence theorem for an nth order differential equation states that every initial value problem will have a unique solution. So unique solution will exist provided your coefficient functions are continuous. a0 a1 extra an and f of x must be continuous in the interval a less than or equal to x less than or equal to b. So that is the basic existence theorem. Ini adupole thanne this is an nth order differential equation. So if you have the functions y1 y2 etc yn which are solutions of this equation, so if they are solutions of the nth order equation, then you know that by the superposition principle, so when you take c1 y1 plus c2 y2 plus etc cn yn, that is again a solution of the differential equation, and these solutions y1 y2 etc yn, they can be linearly independent or they can be linearly dependent. Now they will be linearly independent if, so when you solve for the equation c1 y1 plus c2 y2 plus etc cn yn equal to 0, so provided all the CA's are equal to 0, so CA is equal to 0 for all the I, so in that case it will be independent, and if at least one of the CA is not equal to 0, the solutions will be linearly independent. So if you can find n linearly independent solutions y1 y2 etc yn, so this is the most general form of the solution of a homogeneous equation. Appam idu nammal nth order homogeneous equation ന്റെ കാര്യമാണ് പറയുന്നത്. ഓക്കെ, non-homogeneous there you will have the particular solution also. So for homogeneous equation, so if you have the solutions y1, y2, etc., yn, and if they are linearly independent, then the general solution will be of the form c1y1 plus c2y2 plus etc. cn yn. So here for the linear system of equation, now we will see this analogous result. Appam idhe results linear system applicable aanu. So we will see those results. Okay, so we will now look at the basic existence theorem of linear system of equations. Again, let's go back to the previous class. Not this one. Okay. So this was a system we are having. So I am using this equation again. So that was equation 1. So you have the equation dx by dt equal to a11x plus a12y plus f1 of t, then dy by dt equal to a21x plus a22y plus f2 of t. So let us consider a linear system of equation of this form. So let the functions, so you have the coefficient functions a11 of t, a21 of t, a12 of t and a22 of t, and f1 of t, f2 of t be all continuous on the interval a less than or equal to t less than or equal to b, and let t naught be any point in the interval a less than or equal to t less than or equal to b, and let us take the arbitrary constants. So let c1 c2 be two arbitrary constants. Then the basic existence theorem states that then there exists a unique solution x equal to f of t and y equal to g of t such that, so f at t naught will be equal to c1 and g of t naught will be equal to c2 for all t belongs to the interval ab. So where t belongs to the closed interval a b. So this is analogous to the basic existence theorem in the case of nth order linear differential equation. So all the coefficient functions and your right hand side function provided they are continuous, then for any t naught in the interval a less than or equal to t less than or equal to b, the initial value problem f of t naught, the differential equation together with the initial conditions f of t naught equal to c1 and g of t naught equal to c2, it will always have a unique solution. Okay, for the linear system with the given initial conditions, so unique solution will exist provided the coefficient functions, so a11, a21, a12, a22 and the functions f1 and f2, they must be all continuous. So that is the basic existence theorem for a linear system of equation. And now we will look at the solutions. So how do we get a linear combination of solutions? So let us consider now a homogeneous equation. അപ്പം ആദ്യം existence theorem ശേഷം കണ്ട റിസൾട്ട് ഇതാണ്. So if you have a homogeneous system and if y1, y2 and yn are n solutions, then any linear combination is again a solution. So the same type of result will hold in the case of linear system also. So we will see that result. So consider a homogeneous linear system. So let it be dx by dt equal to a11 of t x plus a12 of t y, and dy by dt is equal to a21 of t x plus a22 of t y. And now let x equal to f1 of t. So that's a theorem. So let, and നമ്മൾ നേരത്തെ കണ്ടതും തിയറമാണ്, എക്സിസ്റ്റൻസ് തിയറം. ഓക്കെ, so let x equal to f1 of t, y equal to g1 of t, and x equal to f2 of t and y equal to g2 of t. So here I have taken two pairs. ആദ്യത്തെ പെയർ എന്ന് പറയുന്ന f1 g1 എന്ന് പറയുന്ന പെയറാണ്, and the second pair is f2 g2. So the speciality of these two pairs are, ഇപ്പോൾ f1 g1 എന്ന് പറയുന്ന പെയർ ഈ ഇക്വേഷൻ സാറ്റിസ്ഫൈ ചെയ്യും, and f2 g2 will satisfy the given homogeneous linear system of equations. So now we will look at how to form a linear combination. So let x equal to f1, y equal to g1, and x equal to f2 and y equal to g2 be two solutions of the homogeneous linear system and let c1 c2 be two arbitrary constants. And now if this is the case, then x equal to c1 f1 of t plus c2 f2 of t and y equal to c1 f2 of t, c1 sorry g2 വരും, g1 ഉം g2 ഉം വരും. So c1 g1 of t plus c2 g2 of t is also a solution. So that is the analogous theorem in the case of linear system. Appo if you are having two pairs of solutions, so if you have the solutions f1 g1 and f2 g2 for a homogeneous system, അങ്ങനെയാണെങ്കിൽ x equal to c1 f1 plus c2 f2 and y equal to c1 g1 plus c2 g2 will be also a solution of the homogeneous system. So this solution is called a linear combination of the solutions. So that is the linear combination here you have. So these solutions are called the linear combinations. Now once you have got different solutions, so the next question is are they independent or dependent? So how to define these solutions are linearly independent or linearly dependent. So Next we look at linearly independent and linearly dependent solutions. So we'll look at the definition. So first we'll look at the definition of linearly dependent solutions. So again we have two set of solutions, x equal to f1, xy equal to f1 g1, adole you have another pair f2 g2. So these solutions f1 g1, these two pairs f1 g1 and the pair f2 g2, they can be linearly independent or linearly dependent. So we look at how to define the solutions are linearly independent or dependent. So let x equal to f1 of t, y equal to g1 of t, and x equal to f2 of t, y equal to g2 of t be two solutions of the homogeneous linear system and now these solutions are said to be, so these solutions are linearly dependent if, so linearly dependent on some a less than or equal to t less than or equal to b if there exist constants c1 c2, so both not 0 such that, so the condition will be c1 f1 of t plus c2 f2 of t equal to 0 and c1 g1 of t plus c2 g2 of t equal to 0 for all t belongs to closed interval AB. So that is a definition for the solutions to be linearly dependent. So if you have two solutions, two pair of solutions f1 g1 and f2 g2, we say that they are linearly dependent if when you solve for the equation c1 f1 plus c2 f2 equal to 0 and c1 g1 plus c2 g2 equal to 0, not all the CAs are equal to 0. So both c1 and c2 must not be equal to 0. Now if both c1 and c2 are equal to 0, so in that case the solutions are said to be linearly dependent. So the solutions are linearly linearly independent if c1 f1 plus c2 f2 equal to 0 and c1 g1 plus c2 g2 equal to 0 gives c1 equal to c2 equal to 0 for all t belongs to closed interval AB. So that's the definition for linear independence and linear dependence. Now in the next class we will look at what will be the form of general solution of general solution of a homogeneous linear system of equation, and this is condition for linear independence and dependence. ഇനി അതുപോലെ നമ്മൾ ordinary differential equation case we have seen how to check the linear independence and dependence using a Wronskian. So we will see the analogous things in the next class. So with that we will conclude. Thank you.